choices? Yeah, you go ahead and sharpen your pencil. You need to sharpen your pencil.
Yes, sir.
Y'all go ahead and get started on it. All right, you got 5 minutes. Make sure you get down the questions and be able to explain your work. Good job, Anthony. Good job, Trey. Good job, Alyssa. Good job, China. Still got 3 minutes, 10 seconds. Good job, Janaya. Good job, John. Looks like everybody done. All right, everybody can get your head up. All right, 3, 2, 1. Ready to rock? Good job. All right. Somebody read. Raise your hand if you want to read today's math start. Raise your hand. Go ahead and get it, John.
What is another way to express
4 squared. I like the way you said that. 4 squared. All right. First of all, before we look at our answer choices, does anybody know what is equal to 4 squared? All right? If we just use the whole number. Go ahead, Trey. 4 times 4. Good job. 4 times 4 is 16. All right, so we're looking for which one of our answer choices are equal to 16. Did anybody get the answer? All right? And it's okay to be wrong. Just let me know what you got. Go ahead, Ms. Rael.
I got A.
You got A, 116. All right? Raise your hand if you agree that it's A. All right, we got 1, 2, 3 agree. Raise your hand if you disagree. And you got something else. John, what did you get? John said B. All right, B is the correct answer. So let's look at this. 1/16. Is that going to be more than a whole? Do I have a whole yet, or do I have less than one whole? Raise your hand. If you have 1/16 of a pizza, is that a whole pizza or less than one whole pizza? Raise your hand. Go ahead, Trey. Is that a whole pizza or less than a pizza? 1/16. Less than a pizza. Less than a whole, right? Is 16 more than one or less than one? It's more than one. So what can we eliminate 1/16? Because that's less than one. We're looking for something way bigger than something less than one, right? So we want to eliminate 1/16. All right? If you remember from our last lessons, fractions are just like little division problems. So let's just do a little division. What's 16 divided by 4, somebody? 16 divided by 4, Rashad. 4. So 16 divided by 4 is equal to 4. All right, let's look at C. Anthony, 8 divided by 1 equals 8. 32 divided by 2 would equal, Ms. Rael, 16. So now, if I'm looking for something that equals 16, if I'm looking for the fraction that equals 16, China, which one of these would be my answer choices if I'm looking for the one that's equal to 16? Is 8 equal to 16? 4 is equal to 16? Make sure you look at all our answer choices. Which one of these are equal to 16? All right, let's go back through these answer choices. B is equal to what? All right, C is equal to? And D is equal to? All right, so if we're looking for the expression that is equal to 16, what will be our answer? B, C, or D? B, what is B equal to? 4, but we're looking for something that's equal to 16. So let's go back, all right? Which one of these are equal to 16? Huh? D, all right, you get where we're going there? You see why it's D? All right, raise your hand if you understand how to answer this question. All right, y'all remember next week we got to go to milestones, so we really want to make sure we can get this today. All right, go ahead. You're going to pass your math start straight to the front of the row. All right. Each person at the front of the row, remember, you're going to shift them down to Rashad. Rashad's going to hand me everybody's, all right? Let's try to get that down in 5 seconds, all right? Got 4 seconds left. Good job, good job, good job. 3 seconds left. 2 seconds left. 1 second left. Appreciate it, appreciate it, appreciate it. Thank you, John, for following the correct procedure. He has his head down. Lets me know he's ready to go. Ready to go. Head down, looking up. Head down, looking up. Lets me know you're ready to go. All right. Let's look at today's standard. We're going to try to go for this oh yeah point. All right. Remember, oh yeah point, we got a minute and 20 seconds. We're going to circle our verbs, underline our nouns, all right? Circle our verbs, underline our nouns. We're going to start with Rashad. Rashad's going to hand it to John. We're going to go to China, then Trey, then Janiyah, then Anthony, and then Alyssa. All right. Use what? It's similar describing something though, John. It's similar describing what? It's describing what? All right, so triangles is our name. And we're going to use similar triangles to do what? To do what? We're going to use that to do what? Look for the next verb. To do what? And it's a verb. All right, we're going to explain. What are we going to explain why what? Why the slope, all right, M is the same between any two distinct what? Two distinct what? There we go. Points, all right? Points on a vertical what? This is a thing, so it's a noun. On a non-vertical what? Line, good job. All right, and this vertical line is in a coordinate plane. Good job. All right, start back at the top. Look at the second half of our standard. Look at that first word. That's our verb. All right, good job. Keep going. Keep going. Get wild. Keep what? Keep what? Keep going. Keep going. Keep going. The equation. Good job. Good job. The equation y equals mx. For a what? This next thing is a thing. Good job, alright? Alright. Through the what? Through the what? Yeah, the origin is a thing. Good job, Trey. Alright, Janiyah's up. And the what? Alright, good job. Equation. That's what we're going to be looking at today. Alright. For a what? Y is mx supposed to be for a line intersecting the vertical what? axis at B. Good job. All right, 3, 2, 1, ready to rock? All right, good job, y'all. You look like we got it. Today we're going to be looking at using similar triangles to explain why the slope M is the same between any two distinct points on a non-vertical line in the coordinate plane. All right, we're going to be really focusing in on the second part of this stand. Derive the equation y equals mx for a line through the origin, and the equation y equals mx plus b for a line intersecting the vertical axis at B. All right? The main thing I want you to focus on today, y'all, is going to be this slope-intercept form. Y equals mx plus b, all right? Y equals mx plus b. All right, I want you to turn to somebody, one of your elbow partners, somebody next to you, all right, and tell them what are we going to be focusing on today. What did I just tell you we're going to be focused on? Make sure I can hear you. I need to hear both people talking. All right, good job, good job, good job, all right? Let's look at this next one, all right? Let me get somebody, remember, if you, remember how we do our essential question, all right? Let me see if anybody remembers how we do our essential question. Go ahead, John. All right, looking at essential question. What's our essential question? How do I graph linear equations? We're going back to review that, y'all, because we got a couple of days before we take the Georgia milestones. We know linear equations is a big part of Georgia milestones, right? Yeah. All right. Read that first learning target there, Mr. Ferguson. Yeah, the first learning target, yes, sir. What are we going to be doing?
Identify y-intercept.
Got to be able to identify the y-intercept first. All right. After that, what do we need to do there, Mr. Walker?
Plot the y-intercept on the graph.
Well, that's the third thing. Plot the y-intercept on the graph. What are we going to do second, Miss Stanley? Want to identify slope. And then the last one, Miss Rael? Use slope to graph a line. All right, y'all. These are the 4 things we're going to be focused on today. All right. We're going to look at something on IXL before we get started, and then we'll review. All right. I'm gonna do a couple of examples. All right, and then I'm gonna have some of y'all come up and do some examples. All right. First thing I'm gonna look at, and some of you guys know this already, is gonna be my equation. So going back to my learning target. All right. What's my first thing I want to be able to do? Raise your hand when you see it. What's the first thing I want to be able to do? John. I want to be able to identify the y-intercept. So if I come back here and look at my equation, which part of this equation is the y-intercept, John? 4, all right? John, come up to the board and plot 4. All right, John, how do you know it was that 4? I see 2 4s on there. Why didn't we put it on that 4 that's on the bottom?
Because if you take like the integer line right here, and then it'll be a positive 4.
That one on the x-axis is a positive 4.
But this your y-intercept, that's why it's
Here we go, all right? Since it's our y-intercept, that means we go into the y-axis, all right? Now, what's the next part of